In this lesson, our topic of discussion is density. Our key areas of discussion are definition of density, the SI unit of density, the formula for density, conversion of units of density, and calculations involving density of substances. What is density? Density can be defined as the mass of a substance per unit volume. This can be written mathematically as density equals to mass all over volume. Using symbols, this is how we write the formula. This particular symbol here is a Greek symbol known as rho, and in this case it stands for the density. M stands for mass and V stands for the volume. We can also use this triangle to make it a little bit brief, and M stands for mass, as we said, V is volume, and rho is density. So it simply means that density equals to mass divided by volume. If you want to make M the subject, you can say mass equals to the density multiplied by the volume, or volume equals to mass divided by density. The SI unit of density is therefore kilograms per cubic meters, which can be written using this symbol kg/m cubed. Another common unit of density is grams per cubic centimeter, and it can be written using this symbol. Let us now convert between kilograms per cubic meters and grams per cubic centimeters. In a simple way, if we want to convert from grams per cubic centimeters to kilograms per cubic meters, we simply multiply the value that we have by 1000. What about if we want to convert from kilograms per cubic meters to grams per cubic centimeters? In this case, we divide the value by 1000. Let's take some few examples. First question, the density of pure water is 1000 kilograms per cubic meters. Convert this density to grams per cubic centimeters. Solution: 1000 kilograms per cubic meters is the same as 1000 divided by 1000, of which the answer is 1 gram per cubic centimeters. Question 2. The density of mercury is 13.6 grams per cubic centimeters. What is this density in kilograms per cubic meters? Solution: we are simply going to multiply the value, that is 13.6 grams per cubic centimeters, by 1000, and this gives rise to 13,600 kilograms per cubic meters. Calculations involving density. First question, calculate the density of a 500 grams carton whose volume is 12.5 cubic centimeters. Solution: first of all, we are going to write what we know, and that is density equals to mass over volume. We already have our mass, which is 500, and our volume is 12.5. So we substitute these values in our formula. So we say density equals to mass, which is 500 grams, divided by volume, which is 12.5 cubic centimeters. If we simplify this, we are going to get 40, and the unit is grams per cubic centimeters. Or if the answer was required in kilograms per cubic meters, we multiply this by 1,000, and this gives us 40,000 kilograms per cubic meters. Question 2. A cylindrical tin of radius 28 centimeters and height 50 centimeters has a mass of 246.4 kilograms. Determine the density of the tin in grams per cubic centimeters, taking pi to be 22/7. Solution. First of all, we can sketch the cylindrical tin this way and label the radius, which is 28 centimeters, and the height 50 centimeters. The first thing is that we need to find the volume of this cylinder since it's not given. So how do we get the volume of a cylinder? It's simply pi r squared h equals to the volume. We are already told to take pi to be 22/7, so we substitute this 22/7 times the radius, which is 28, but then squared, multiplied by the height, which is 50 centimeters. This simplifies to 123,200 cubic centimeters, and that's our volume. Now, we need to convert this mass into grams. So, how do we convert the mass into grams? To convert kilograms into grams, we simply multiply by 1,000, and this will give us 246,400 grams. Now it is very simple because we now get back to our formula, which is density equals to mass over volume, and we already have our mass and our volume. So we substitute in this formula. So we say density equals to mass, which is 246,400 grams, divided by volume, which is 123,200 cubic centimeters. This therefore simplifies to 2 grams per cubic centimeters. And that's it. That's the answer that was required. Question 3. Given that the density of ethanol is 800 kilograms per cubic meters, what volume would 160 kilograms of ethanol occupy? Solution. We begin from what we know, and that is the formula, density equals to mass over volume. Then the next step is to substitute for what we have, and that is density is already 800 kilograms per cubic meters. This equals to the mass, which we know, that is 160 kilograms, divided by volume that we don't know, so let it be V. Now we rearrange this equation, and eventually it implies that V equals to 160 kilograms divided by 800 kilograms per cubic meters. This simplifies to 0.2 cubic meters. Now try out the following question. Determine the density of a solid 5 kilograms having a volume of 12 cubic meters. Leave your answer in grams per cubic centimeters. Thank you, and I hope to meet you in the next lesson. Goodbye.